Here is our last lesson for chapter 1 in geometry. We're on 1.9 and we're doing a little throwback today. We're going to review probability. Now, probability may seem like something you did a long time ago. That's a lot of algebra that doesn't seem to fit, but it's something that's going to pop up a lot this year in geometry. It is a concept that you've learned before, that you've done a million times, but it is also something that we can do a lot with once we learn some new geometry concepts. So we're going to review what probability is a little bit, and then I'm going to show you how it's going to show up in geometry this year. So before we get into it, we have our little warm-up, and our warm-up today fits perfectly in. I was pretty excited when I saw this Doritos roulette. I had never seen them before. I think this is awesome, and I kind of want to try it. So go ahead and watch the video if you haven't yet, and then see if you can figure out what the probability is that you will eat a hot chip, and explain your thinking. All right, so if you watched the video, you saw that it ended up that there were 13 hot chips out of, and there were 99 total chips, right? So the probability then, if you remember what probability is all about, probability is a fraction where I have the number of good possibilities, or the ones that I want, on the top, and the total number on the bottom of that fraction, right? So in this case, my probability would be 13 out of 99. Okay, now probability is sometimes represented as a fraction, sometimes represented as a decimal, sometimes represented as a percent. Most often in this class, we're just gonna leave it as the fraction. So 13 out of 99, I know I can't reduce it because 13 doesn't have any factors, so I can't reduce that at all. But so we could say 13 out of 99. Sometimes, though, we would take that and we should change it into a decimal. So I'd get my calculator out here and I would type in 13 divided by 99. And I would get a crazy decimal that doesn't end and keeps on repeating. So 0.131313 dot 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 dot. And yes, that's the same thing as writing 0.13 with the bar above the 1 and the 3. But that's technically not as accurate as 13 out of 99. So we would really want to leave that as the fraction if you get something like this. If it did tell you wanted to get a percent and you wanted to round it, we could say that this was 13, 0.13% if we wanted to, or something like that. But we still want to, probably the best way to write this would be to leave it as a fraction. So I would say, unless it tells you otherwise, plan on leaving your answers as fractions. So about 13% chance that you're going to get a hot chip. Now, I know what you're thinking, and you're probably thinking, who would buy that bag of chips? We love hot chips. What I'm thinking is, ooh, that's too risky. I don't want 13 out of 99 chips to be hot. I hate hot foods. But kind of a fun way to get you back into that idea of probability. So number of good options out of the total number of options. So we're just going to take that now and say, all right, well, what's that going to look like in geometry? Okay, so here I have an angle with some points on it, right? Points A, B, C, and D, and says if 2 of the 4 points are chosen at random, what is the probability that they both lie on ray CA? Okay, now we do know that there are a million other points in that, an infinite number of points in that picture, but we're only going to talk about the 4 that are actually listed. And so what I'm looking at here is, if I pick any 2 points, what is the probability that they will be on that ray, starting at C, endpoint at C, going on forever in the direction of A, like this, right? Okay. Now, it says for us to pick 2 points, right? It doesn't say for us to pick one and then put it back and pick another, or for us to pick one and keep it and then pick another. We're picking out 2 at the same time. So this is going to be one fraction, right? This is one event, probability equals, and I need that one fraction. Okay. So how am I going to figure out what the good choices are? I'm picking out 2. So I kind of think of left hand and right hand here. So if I reached in with my left hand, we'll say left hand's going to be in red and right hand is going to be in blue. If I reached in, I have these 4 letters, A, B, C, and D in a bag, and I reached in with both hands. I could pick out, say, letter A with my left hand and letter B with my right hand, right? There's one combo. I could pick out letter A with my left hand and letter C with my right hand. I could pick out letter A with my left hand and letter D with my right hand. Those are all possibilities, right? Well, I could also pick out letter B with my left hand and letter A with my right hand. Letter B with my left hand and letter C with my right hand. Notice I can't pick B with both hands, right? There's only one B in there. Okay, and on and on and on and on and on, right? Dot, 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 dot. So this could take a while, but I could list out every single possibility. It's an option, right? And then go back and check out what are my good options. Maybe faster way would just to be, all right, what are my good options? What would I be looking for here? So let's see. I could have A and B as a good option. I could have A and C as a good option. I could also have B and A as a good option, right? I could have C and A as a good option. I could have B and C as a good option. C and B as a good option. I could have, let's see, so I have AB, AC, BC, CB, and CA. 1, 2, 3, 4, 5, 6. I believe that might be it. Let's see. Okay. So then I have 6 good options. So if I could list every single one of these out, right, and I could count them all up. That seems like a long time. If you wanted to, you could check out on your next slide. It shows how they have done that. Now, they didn't take into account the reverse order, but, you know, that kind of goes along with the same idea. Now, what about the total number of possibilities? So I could list them all out and count them all up, but let's think if there's a faster way. So for my total possibilities, I'm trying to pick out how many points. I'm picking out 2 letters here, right? So I really have 2 spots that I'm trying to fill. How many options do I have for the first spot? When I reach in, say my left hand's a little bit faster than my right hand, how many options are there when I reach in with my left hand? Well, there's 4 points there, right? So there are 4 options for my left hand. Now I grab one with my left hand. How many options are for my right hand as I'm scrabbling around in the bag? There's only 3 left, right? I don't have an infinite number, like that B doesn't regenerate or that A doesn't regenerate. So I have 4 options for that faster hand, and I only have 3 options left for my second hand, and I pull those out. So for every one of those 4 options for my left hand, I have 3 different options for my right hand. So I'm going to multiply those together. So that gives me 12 total options. Now this idea here, where how many spots am I trying to fill and how many options for each spot, this is actually called the counting principle. I don't know why they call it the counting principle. Sometimes they call it the multiplication principle, but that's what it's called in probability. And so that's a really good time saver. I think I just spelled principle wrong, but you get the idea. How about with a P, whoops, instead of a B? There we go. So that's a really good time saver, is to figure out that way how many options for my first hand, how many options for my second. It would actually have worked for my good options as well, right? So for here, I'm also trying to fill 2 spots, but only these 3 points will work here, right? So how many options for my first spot is 3 with my left hand. I grab that one. I only have 2 options for my second hand, and that gives us the 6 that we had found by listing it out. So that counting principle is a big time saver. So my probability is 6 out of 12. Now, we don't ever want to leave a fraction like that. If we can reduce it, we always, always, always want to reduce it. It will never tell us to do that in the directions that we need to do it. So in fact, my probability that 2 of these 4 points at random both lie on ray CA is 1/2. Okay, so big thing here is remembering that counting principle, but also remembering, like, if they ask you to grab more than one thing at once, it's not grabbing and putting back or grabbing and keeping and grabbing again, then it's one fraction, right? That's one event, so keep that in mind. All right, so here is the same picture, exactly the same thing happening, except this time I have 3 points that are chosen at random. And what is the probability that they correctly name angle C? So again, I'm going for probability here. It's my fraction. Now they need to correctly name angle C, but I have to use 3 points. So just saying C doesn't work. So let's see if we can figure out our ways of naming the good possibilities, right? So before I do counting principle, I'm going to really just kind of list them out for this one. This one kind of might work better that way. So I could say angle ACD, right? I could say angle BCD. I could say angle DCB. I could say angle DCA, right? No matter what, I have to have that C as my vertex. So that one has to be in the middle. I believe those are all of the good possibilities. So maybe it was a little bit faster even to do just the listing them out on this one because it was a little more complicated than just picking 2. So there are 4 good possibilities here for naming angle C. Now when I get to my total possibilities though, maybe we can shorten this one up, because if I had to list out every single way I could list 3 of those 4 letters, whew, boy, that would take forever. So let's use that counting principle. This time, how many spots am I trying to fill? How many things am I picking out? I'm picking out 3 things, right? So I have 3 spots to fill this time. How many options do I have? The first time I reach into that one, I'm reaching in with 3 hands, right? For the first point, how many options are in there? 1, 2, 3, 4 options. So 4 options for my first point here when I grab with my first hand in there. All right, then how many options do I have for the second point that I am reaching in for? The second point I grabbed 1, now I have 3, left. Okay, and now I've grabbed the first one and the second one, and how many options do I have after that? I only have 2 options left once I've grabbed the first one and the second one, and now I have my 3 points. So I need to multiply those out, right? So for for all 4 of those first ones, I have 3 options for the second one, and for all 3 of those options, I have 2 options for the last one. So that means 4 times 3 is 12 times 2 is 24 24 total options. So I have 4 out of 24 for this one. Again, I can reduce that, so I'm not going to leave it as 4 over 24. I'm going to reduce it, and I'm going to get 1/6. So again, I was picking 3 points out. That was all one thing, so it's one big fraction. List out those good ones. This time it was easier just to list them, but save some time with that counting principle, especially for that total number of options. How many spots are you trying to fill? How many options do you have for each spot? And multiply those options together. Okay, one more here just to, again, change it up. We were looking at the angles and the points. How about if we give a segment? So on this one it says, point Q is randomly chosen on segment AB, right? So anywhere on this segment, I'm going to pick a point. I'm going to throw a dart and it's going to be point Q, and that's where it's going to land. So what's the probability that it is within 5 units of C? The probability that it is within 5 units of C. So I need to go 5 units to the left, right? This needs to be 5 away. Oop, hard to write with a highlighter. So 5 units to this direction, but it also could be 5 units to the other direction, right? right, so I could have 5 units this way. Wait a second. That doesn't quite make sense, right? 11 to 15, that's actually only 4 units. So I can't go 5 units away from C to the right because I only have 4 units to go with. I have to end here. So I have 5 units going to the left, but I only have 4 units going to the right. Okay, so if I'm setting up my probability here, my probability, the amount of good options that I have, I don't have the full 5 in both directions. I have 5 to the left and I have 4 to the right. So the total length there is actually 9, right? Not 10, because I can't go all the 5 all the way to the right. So the total good length for options is 9, but what is the total length of segment AB? Because that's my total possibility, right? So total would be, well, let's see, from 3 to 15, which is 12. So I only have 9 good, but I have 12 total. So then I can reduce that, divide both by 3, and I get 3/4 as my probability that point Q will land within 5 units of C. But notice I was talking length on this one, right? But I couldn't go the full length they were talking about to the right, so it's not just, what's on the number line, but it's how many good that I could possibly do. So probability there of 3/4. Hopefully that helps you see some different ways that you could see probability in geometry. So picking out points just like before, remembering that counting principle, but also seeing segments and thinking about length of segments as well as just picking things out of a bag. That's kind of it, right? So remember, if you're picking 2 things at the same time, that's one event and should be one fraction. Save time using that counting principle. How many spots are you trying to fill and how many options for each spot, and then multiply them up. If you are going to make a list, which you can if you don't want to save that time using the counting principle, keep it organized somehow. Just don't write them all down willy-nilly. Make sure that you're getting all of them somehow. All right, hope that helps. You've got some probability problems there from page 51 for homework tonight. And probability is something that just happens to pop up all the time for you guys. If you are somebody that struggles a little bit with probability, do those extra practice ones as well, because it just doesn't hurt. There's something that pops up all the time that we don't spend a lot of time teaching.